Hi, welcome to this exercise on floats. So continuing from the integer exercise where we used the calculator, we're going to use a calculator now as well, but now we upgraded it to be a float calculator. And when I say upgraded, it sounds like floats are always better than ints. I mean, that's not true. We're using ints a lot. So ints are nice because they are exact and they're very useful in programming in general. But floats have the advantage when we want to be exact in the number of decimals or the decimal part of a number. So if we do 10 divided by 3, we can get something like we see on the calculator there, 3 point a lot of threes. We won't have an infinite amount of threes though. So I mean at some point it's going to end here. And this is where floats also become a little bit less exact, that you might have a 5 at the end there, for example, at some point where it's not relevant anymore. So it is for sure to be exact up to some number of decimal places, but then it doesn't really matter. So, but that's an important thing to remember when it comes to handling floats and using floats in programming, that it's only relevant with a certain number of decimal points, which will be enough to do anything useful with them. But when we, for example, compare two floats, we need to know that it needs to be done in a special way that we're going to go through in the exercises as well. And we're going to go through all the normal operations like multiplication, division, addition, subtraction. And we know then from looking here that division is different from integer division. We don't get, before we looked at the modulo operation, how to look at the remainder. With float number division, we get the decimal places as well. And then we're going to look at comparison also. And also we're going to look at absolute value, which is removing the sign from the number. But let's go to the editor here. So now I'm going to go through what you're supposed to do in the different levels, but I'm not going to show the solution. So in the first level, we're going to do addition, which is basically just returning a plus b. And then we have subtraction in level 2, a minus b. In level 3, multiplication, just a times b. And then in level 4, we have division, a divided by b. And if we jump to level 5, then we have absolute value. So then we should do abs, which typically you will see how to do it in the description window to the left. So abs of a will return, in the Python case, the absolute value of a. Most languages, I think it is abs, but there might be some, it will change here if it's different in this language. Which one is typically, could be different, could also be Go maybe, yeah. So here we have to write math.abs in Go, for example. But in Python it's just abs of a. And now let's go to float comparison. So I talked about that a little bit, that it's one of the things where it's tricky when it comes to floats. And why is it tricky? Well, we can see that in the image there, that in this first case, we want to compare two numbers, and they are virtually the same, but as you see here in the end, they are actually different. One ends with a 5, one just ends abruptly, and it's not relevant basically. When you have that many decimal places, the ending is no more relevant. So we should say that these two numbers are the same, as you see here. And then we have the other example where it's deviating only in the, this is the 6th decimal place. And that is a bit too early for it to be considered the same number. So here we should return false. They are not the same in our equality check. So how do we do that? Well, first let's look at how not to do it. We should not write just a equals b. That's the problem with floats. So that's one thing to remember is don't ever compare them like that. Instead, what we want to do is we want to use abs that we looked at right now in one of the other exercises. So we take a minus b. We want to look at the difference between a and b, but we're not interested in the sign because we want to do the comparison less than and then some very low number. So this can be math.pow for power 10 to to the power of minus 10 or something. But I'm just going to write here 0 point whatever the accuracy is that we want. So now I'm in actually the 6th place. So maybe I should have done that with even more decimal places. But this is the idea anyway. And it could be something like, can also use something like this, which I think is the Python example. Should check this beforehand, but yeah, this you want to compare it to a very, very small number. And then you say that that's enough. If that, whatever the difference is here, if that is less than this very, very small number, then we are happy. And we do abs to get the absolute value, just to get this comparison right. If we didn't do abs, if we forgot that part, then whenever b is larger than a, we will get a negative number, and then this would always be true. So then we would not do a valid comparison anymore. Then we'll say that the numbers are equal just because b is lower than a. That's not what we want. So we're going to do a comparison, find the difference between them. We do the absolute value to remove the sign, and then we see that whatever the difference is should be lower than some very, very small number, close to 0. And that's how you compare floats. And that's what you will see here in the level 6, the final exercise of floats. There's also more information here in the description window, basically saying what I just said now. So, yeah, good luck solving that.